New topic, FLUVIATILE plains and alluvial slopes. Sounds like a novel. FLUVIATILE. Let's check the dictionary. Belonging to rivers or streams. Oh, we're going to different bodies or kinds of bodies of water and seeing what we can find that be plausible of how that stream got to be like that there without imagining. Just speak from a plausible point of view. Nor are there geosynclines, there's another word, nor are the geosynclines the only depositional feature of physiography which seem unrelated to any sort of deposits being formed at the present time. There's that word geosynclines. You have to get a vocabulary book, a geology dictionary. Well, we got a dictionary here. Geosynclines. G-E-O-S synchronal. Okay. Syncline, synchronal. The downward bend or subsidence of the Earth's crust, which allows of the gradual accumulation of sediment and hence forms the first step in the making of a mountain range. Okay. So they project that this was a slow process. And the answer to that is, nor are the geosynclines the only depositional feature of physiography which seem unrelated to any sort of deposits being formed at the present time. So the geosynclines were unrelated because they drew those conclusions out of their own imagination. And we have a lot of anomalies we looked at. Now we're looking at fluviatile plains and alluvial slopes. The large central region of the United States, known as the Great Plains, stretches roughly from the Rockies to the Mississippi and from Canada to Mexico. It consists, the Great Plains, consists largely of remnants of a single great fluviatile plain, defined as fluviatile, produced by stream or river action or alluvial slope. A slope formed of material deposited by running water, clay, sand, silt, gravel, and so on. Here again one must visualize a phenomenon for which there is no parallel in the modern world except on a much smaller scale. Yeah, see, you see this stuff, smaller scale, you might imagine stuff happening locally over a long period of time. But when they actually it can happen rapidly as well. Plausible for both. But a huge plain on a huge scale, it's hard to realize that local little stuff can go hundreds of millions of years, little drop here, little pebble there. Here again one must visualize a phenomenon for which there is no parallel in the modern world except on a much smaller scale. The principle of uniformity is misnamed if, to interpret ancient phenomena on the basis of the present, the expedient of extrapolation beyond normalcy must so continually be developed and to such a degree. Almost everywhere one looks, he can find evidence of widespread deposition, either alluvial or deltaic in nature, of magnitude quite beyond that of any deposits being formed in the present. There's another word, deltaic. Well, delta. What's a river delta? A river plain, I guess. Mountain-bearing sediments in the Uinta Mountains of Utah are believed by evolutionists to have been derived from the wearing down of more than 7,000 cubic miles, wow, from the summit of a great fold, filling in the surrounding area to a depth of at least several thousand feet deep, up almost to the summits of the remaining mountains themselves. After the formation of the new anomalous, abnormal, not in accordance with present-day processes, rivers on these tremendous alluvial deposits, another uplift is postulated by evolutionists. It's a guesswork, or just explaining it beyond comprehension and common sense. Still another evidence that present-day rates of erosion and deposition cannot account for the ancient deposits as they are found. Probably would take longer than they estimate the entire universe is old. Well, a lot of times they run themselves up an argument that's is just so bad that it's comedic. We have large, high plateaus and spectacular canyons with uniform horizontal strata. Another major difficulty of the uniformitarian concept of sedimentary processes is found in those great areas of very thick deposits, which have gone through one or more cycles of uplift and submergence, and yet remain marvelously horizontal and continuous. A good example is found in the Colorado Plateaus. Describing this province, Fenneman says, that's N.M. Fenneman, Physiography of Western United States, McGraw-Hill textbook, undergraduate. The first distinguishing feature is approximate horizontality of its rocks. The second distinguishing feature of the province is called elevation. Aside from the canyon bottoms, no considerable portion of it is lower than 5,000 feet. Between this and 11,000 feet, there are plateaus of all altitudes, some of them being higher than the nearby mountain range. You got a mountain over here, you got a plateau over there. And like it says, it pictures mountains rising halfway up. They seem to be kind of like stumped at the bottom and just a little peaking of it there, because then there are mountains nearby that are huge. And this is best explained as some catastrophic thing, like a worldwide flood. This region occupies some 250,000 square miles, including most of Utah and Arizona, with large segments of Colorado and New Mexico. The Grand Canyon and many other spectacular canyons have been excavated through thousands of feet on these flat-lying sedimentary rocks. The remarkable thing is that this entire region has somehow been uplifted from far below sea level, since most of its sediments are of marine origin, to over a mile above sea level, without disturbing the horizontality of the strata or summit levels. And this has happened not once, but many times, since there are several disconformities in the stratigraphic sequence of these sediments, each, according to the evolutionists, supposedly representing a period of uplift and erosion followed by subsidence and deposition. But the problem is it's so ununiform and so vast. Something had to happen quickly. You can't have a little uplift mountain here and then sediment right there, and then a mountain next to it is 5 times taller, and it didn't happen over there. No wonder Kennedy says the problem of the uplift of large plateau areas is one that has puzzled students of the Earth's crust for a very long time. George C. Kennedy. Uniformist concepts, furthermore, have apparently proved incapable of providing a satisfactory solution. It seems much more likely that the sediments all were deposited more or less rapidly and continuously, followed by a single great regional uplift. Yeah, stuff can happen all of a sudden, and then a local uplift, but it has to be catastrophic, not gradual. Subsequent rapid canyon downcutting then ensued from the draining flood waters, while the sediments were still relatively soft, and the rivers were carrying much larger discharges. Spectacular exposures of flat-lying sedimentary rocks, are such as in the Grand Canyon, provide ample visible evidence of deluge deposition. In this area, there are thousands of square miles of horizontal strata, thousands of feet thick, supposed to have been deposited over 500 million years. The strata include limestone, shale, and sandstones. According to uniformist concepts, numerous changes of environment with great regional subsidences and uplifts must have been involved, but this would appear quite impossible. The strata simply could not have remained so nearly uniform and horizontal over such great areas and great periods of time, while undergoing such repeated epeirogenic deforming movements. By far the most reasonable way of accounting for them is in terms of relatively rapid deposition out of the sediment-laden water of the flood. Following the flood, while the rocks were still comparatively soft and unconsolidated, the great canyons were rapidly scoured out as the waters rushed down from the newly uplifted peneplains, large erosion-formed plain, to the newly enlarged ocean basins. All happens at once on such big scale, easy to understand. But, the evolutionists, if there's a lot of explanation going on, they'll invent all kinds of things here and there, and they don't have to be consistent. The canyons in these plateau regions present another mystery for which uniformitarian explanations have proved inadequate. Sinuous, meandering rivers at canyon bottoms. Many of them are strongly sinuous and meandering in their courses. Sinuous, bending in and out of a serpentine or undulating form, winding crooked, as we discussed these streams, and canyons. Many of them are strongly sinuous and meandering in their courses, looking very much like the typically meandering mature rivers winding across alluvial plains, except that the canyons are hundreds of feet deep and the meander patterns are even sharper than in alluvial rivers. These are called incised or carved or entrenched, eroded downward, meanders in view of their presumed entrenchment in the regional bedrocks during the process of uplifting. That is, it is supposed by evolutionists that the entire area was once near sea level with an alluvial blanket of sediment on its surface. Evolutionists go on to say that on the surface flowed typical alluvial rivers with a typical meandering patterns. Then, according to the evolutionists' theory, the process of regional uplift was initiated. The rivers which before had been eroding laterally now began to erode vertically. Wow, rivers erode vertically. But in the process maintained their same meandering course, thus incising the pattern deep into the rocks of the plateau. Problem with that is, like the Grand Canyon, there appears on the Colorado River bedrock underneath. It looks like the river or water that came through the Grand Canyon area washed away everything until it went down to bedrock, and the side of the canyon is rock. So it took everything that was loose. Bingo, there it's done. Don't have to go to 15 encyclopedia volumes to explain everything in the Grand Canyon, and then figure out why it's so much older than the universe is old. Joseph Friedkin, a laboratory study of the meanderings of alluvial rivers. So, further comment. If the bed is subject to down cutting at all, it will be eroded rather than the banks, since the greatest tractive, drawing, pulling, adhesive friction stresses are directed along the bed rather than at the sides of a stream. That's right, it goes all the way down to the bed, and when you get stuff pushed away by the flowing waters, however violent or deep, then all you have left is rock underneath and rock on the sides. And that's exactly what you find. A stream which is degrading its bed